Good morning. Good morning, everyone. Happy Lunar New Year to all of you. I hope everyone's doing well. Just a quick reminder, as Francine has up the instructions for the CME, reminder that you're texting the 7688 number to that. Just reminding everyone, because not everyone is doing it yet. And just want to make sure this is the only way to get credit for CME as of January of this year. So with that, I want to thank the Seckler family for their support for this lectureship, and I will turn it over to Dr. Levin to introduce our speaker.
Thank you, Dr. Thomas, and good morning, everyone. So today we're very pleased to have Dr. Joseph Masci joining us as the recipient of the Stanley Seckler Award for Clinical and Educational Excellence in Medicine. This lectureship is awarded to a clinician educator that embodies the spirit of Dr. Seckler. Dr. Stanley Seckler completed his residency at the Mount Sinai Hospital in 1956 and became an associate dean at Mount Sinai from 1983 to 1987, and the director of medicine at Elmhurst Medical Center from 1964 to 1987. Dr. Seckler was also a renowned professor of clinical medicine at the School of Medicine at Mount Sinai. He was famed for his yearly clinical pathology conferences, during which he would be presented with some extremely difficult cases and challenged to deliver the correct diagnosis. Dr. Seckler was best known as an outstanding diagnostician with an encyclopedic knowledge of internal medicine and served as a lasting inspiration to hundreds of residents and students. It is my great pleasure to award Dr. Masci with this award, which I will be bringing to you at Elmhurst this week. Throughout his career in infectious diseases, Dr. Masci has served as the Associate Director and the Director of the Department of Medicine at Elmhurst Hospital Center and the Chairman of Global Health. His work on HIV and AIDS treatment and care delivery has advanced the field on a local and international level, including founding the AIDS program at Elmhurst, service for the New York State AIDS Institute, chairing the Health Services Work Group for the NYC HIV Planning Committee, and organizing federally funded HIV/AIDS programs in Ethiopia and Russia, in addition to numerous publications, books, and book chapters on the subject. Since the early 2000s, Dr. Masci has been heavily involved in planning strategies for bioterrorism in response to infectious disease public health emergencies at the city level, including for both Ebola and COVID-19, and serves as a consultant to the United Nations Medical Corps on COVID-19 and other infectious diseases. Finally, it is most important to me to mention that in addition to his numerous accolades, Dr. Masci has remained dedicated to his patients and to us, his residents. Throughout my 4 years of training, Dr. Masci has remained a fixture of my training at Elmhurst and has always availed himself to help. He's not only an expert in infectious diseases, but also as an internist. He is an internist in the truest sense, and a mentor who has fostered an excitement in medicine for so many of us and empowered us to be our best. Thank you so much for joining us today.
Thank you. Thanks so much for that generous introduction. Let me attempt to share my screen now. Let me say a few words of my own about Dr. Seckler. We overlapped a little bit at Elmhurst. I joined the Elmhurst faculty in 1982, and he died rather unexpectedly in 1987. He was extraordinary as a teacher. Many of you remember his clinical brilliance, as Emily mentioned. His rounds at Elmhurst were unique. He would spend 3 or 4 hours exploring in great detail an individual case. And as a result of that, he revealed to all of us how you could get into the personal side of clinical illness for any patient. And he is the proud holder of many memories among generations of house staff here. And I'm really honored to give this lecture in his name. Thank you. I'll try to move on. Okay, so my topic is going to be, sorry, let's get some of these things out of the way. My topic is going to be climate change. We all hear a lot about this, but because of the COVID pandemic, a lot has been distracted away from the urgency of climate change. I'm going to speak about it, show you some of the same information you've seen over the years and how it's getting worse and worse. And at the end, I'm going to try to speculate at least on our potential role as physicians in this. If you notice the date on this New York Times story, global warming has begun, experts tell the Senate, June 1988. So, well over 30 years ago, this was already considered a major coming disaster. And if you see the graph, you see what we're seeing in graphs ever since then, this continually rising level of global warmness, global temperature. So this is nothing new. What's new is an increased urgency about the immediacy of it, as well as the beginnings of efforts to do something about it. So just to give you some background on this, CO2 doubles projected to double by 800 parts per million by the year 2000. If you look at where we are today, that line at the bottom, you see that since 1988, when that article was published, we've gone up considerably in the amount of CO2 in the atmosphere. This is largely due to the greenhouse gas effect and the global warming that comes with release of CO2. Earth absorbs solar energy and emits this as heat. Greenhouse gases, such as carbon dioxide, methane, nitrous oxide, and sulfur hexafluoride, accumulate in the atmosphere and reflect this heat back to Earth. That is the reason why the climate seems to be getting warmer steadily. There is a natural greenhouse effect, and that's because the sun obviously warms the Earth, and our atmosphere keeps a lot of that heat in. Oceans warm from the sun, et cetera. But this enhanced human greenhouse effect is because of this material that we're releasing continuously into the atmosphere. So where is global warming going? It's going primarily into the ocean. That seems like it's something of a shield. It really isn't, because the ocean includes glaciers, and the ocean is liable to continue to rise steadily over the course of the next century. Human activity is the driver to this. There's a consensus now among basically all scientists on this, that the climate change that we're seeing and the global temperature rise that we're seeing is due very little to the solar effects directly. It's due primarily to the human-caused release of carbon dioxide into the atmosphere. If greenhouse gas levels like carbon dioxide were actually stabilized today, then the expected warming would still be about 1.1 degrees Fahrenheit by 2100, which in itself would be catastrophic. There are lots of indications that point to us as the cause of all of this. Just to mention a couple, we have the cooling of the stratosphere is related to global warming that we're producing, rising of the tropopause. This is the climate surge that comes in the Pacific that results in the rising temperature in the tropopause, the rising outer layer of the atmosphere, et cetera. There's more fossil fuel carbon in the air at all times and more heat returning to Earth. You see the statistic, 300 billion tons of CO2 per year are released into the atmosphere. Global temperatures are continuing to rise. You see the graph on the left. Basically every year since 1939, actually, the global temperature has risen steadily. There have been a couple of minor exceptions to this, but particularly over the last 20 years, it's risen particularly dramatically. This change in temperature has been in all continents, more severe in some areas than others, but it's truly a global phenomenon. Arctic sea loss, change in ENSO amplitude, that's the wave pattern in the Pacific, dieback of various rainforests, the greening of the Sahara, et cetera. All these are directly due to climate change. And to continue to show you some maps, the global distribution of vulnerability you see on this map, the extreme vulnerability countries you see in red. These are primarily the countries of Africa, South Asia, the Middle East, and South America. We are at moderate risk from all of this in terms of our vulnerability because we're a more developed society than many of those countries and because we're in a relatively temperate zone compared to them. But all of us are going to be victimized by this. We'll come back to Africa in a minute. The projected impact of climate change on agricultural yields, again, particularly hitting Africa, South Asia, South America, but look at the United States in this. The impact on crops in the Southwest and in the Southeast is going to be dramatic because of climate change. The areas at most risk in Africa are the areas that are in this hatched red zone, particularly the countries you see in that zone, just south of the Sahara Desert, because the desert is going to be getting larger. Countries in South Africa, like Botswana, Mozambique, et cetera, they will be becoming more and more semi-arid compared to what they are now. The ice caps, of course, are melting. This is a story that appears in the news every few weeks. Large chunks of both polar ice caps are breaking off. Responsibility for all of this is highlighted in the red countries. We lead the list in the responsibility for climate change. The color reflects the amount of carbon dioxide released into the atmosphere, and you see on the left the scale, it's tons per capita. The countries in red releasing the most, the countries in green releasing the least, and as you can see, those countries in green, particularly in South and Central Africa, are at highest risk, although they're releasing the least carbon dioxide. The vulnerability, of course, again, Africa. To hammer home this point, Africa is at extreme risk because of climate change. So the impact we see in many ways. We talk about it just as warming, but there's a lot more to it than that. There's more severe weather in all directions. There's more air pollution. There are more vector-borne diseases, which I'll come to in a minute. Allergies are worse when pollen is released into the air because of warm temperatures. Water-borne diseases are getting more common. Cholera has spread to new areas of the world. Environmental refugees, obviously, are a major source of the impact of this. And what's anticipated is refugees from those northern countries in Africa, many of which will lose their arable land, will be headed for Europe in the future in much larger numbers than have gone so far. The mental health impacts of this are a little harder to calculate, but they include anxiety, despair, depression, some of the same things that we've seen with COVID. And of course, the water and food supply has increasing risk of becoming contaminated because of climate change and global warming. So temperature-related disease and deaths, air quality impacts, extreme events, vector-borne infectious diseases, waterborne related illness, food safety, nutrition and distribution, mental health and well-being. I'm going to touch on a few of these topics in more detail now. Effects on general health. Between 2030 and 2050, approximately 250,000 additional cases, deaths per year will be directly attributed to climate change. Now that projection is getting steeper and steeper as the years go by, and will probably continue to rise. What that projection is said to be for those years. In developing countries that have weak infrastructure will be the most affected and the least able to respond. The impact of climate change on infectious diseases, my area, vector-borne, waterborne, foodborne diseases, and drought all contribute to the increase in insect and other vector-borne infections. Warmer temperatures and changes in precipitation are affecting the habitats and the mating cycles of mosquitoes and ticks. All of the vectors are rapidly becoming more common and widespread. Aedes aegypti, mosquito that causes dengue, yellow fever, and Zika is now found in 28 states in the United States. It was first found for the first time in the United States in 2013. It's now present there in 56 counties. Culex mosquitoes that spread West Nile fever are more prominent now. Ixodes scapularis ticks that spread Lyme are getting more common. Now, the reason for this is particularly illustrated by the problem with dengue. Dengue, if you go back 50 years, was a very rare infection globally. Now it's a very common infection globally. And part of the reason for that is that it is transmitted in a way that is directly affected by climate change. We have students at Elmhurst frequently who come from St. George's Medical School in the Caribbean. They didn't used to have dengue in that part of the Caribbean. Now they have so much of it that the students are continually being tested for dengue. And they have a number of students out each year because of dengue. This is all not directly because of heat. It's because of the expanding geographic distribution of these insect vectors. In the United States, 50% of outbreaks globally of infectious diseases due to waterborne illnesses are after extreme rainfall. You might think rainfall is not going to be an issue with climate change, but it definitely is. And we've seen the enormous surge in precipitation in parts of our country this year. Warmer water increases the proliferation of bacteria, particularly, for example, Vibrios, as well as algae. You see an algae bloom at the bottom in that picture. Algae blooms are considered extremely dangerous now because of the toxins that are released and the contamination of ocean water that they result in. Foodborne illnesses. There are 48 million cases in the United States each year, 120,000 hospitalizations, and 3,000 deaths. Of course, in comparison to COVID, that doesn't seem like much, but this is something that we have some control over going forward. Increasing ambient temperatures increase the replication of a lot of foodborne bacteria like Salmonella, E. coli, and Campylobacter. And refrigerating food, this is, in our country, not as severe a problem as it might be. It is a very big problem in other parts of the world. Africa, South America, South Asia, for example. And we saw how critically important maintaining low temperatures for storage is in the distribution of the COVID vaccine, which initially was halted to these subtropical and tropical climates because it couldn't be adequately refrigerated. Well, the same goes for food in those countries. Drought-related disease. With decreases in natural water supply, mosquitoes become more common in domestic standing water. The increase in likelihood of contact between mosquitoes and birds is seen with West Nile fever. Now, mosquitoes, very interesting. Mosquitoes really cannot live above an altitude of about 2,000 feet above sea level. But that's because of the temperature. It gets too cool for mosquitoes above that level. But now as the temperature is getting warmer, that cutoff line above which mosquitoes can't exist is getting higher and higher. So the population of mosquitoes globally is increasing enormously because of climate change. Extreme weather and natural disasters, we all have witnessed this directly and indirectly for years now. Specifically, warmer and drier conditions lead to a longer pollen season, increasing CO2 in the air because of that. Higher humidity and flooding leads to dampness, growth of mold indoors, increasing allergies, and worsening asthma. It's been found, for example, that childhood asthma in crowded neighborhoods in New York, for example, Harlem, Elmhurst, is primarily due to mold spores and pollen that is released from materials that are in apartments, in crowded apartments that are not possible to be cleaned very effectively. So cleaning efforts for these apartments have been developed to try to reduce the risk of asthma to young children living there. But those efforts are expensive and have not been dramatically increased yet. So the impact of the efforts is yet to be really seen in that. But the impact of the dampness and the high humidity and the dirty drapes and rugs, et cetera, in many of these buildings is increasingly common and obvious to us as childhood asthma. So the coasts that are particularly vulnerable to sea rise, you see that are I highlighted here in red. It's the entire east coast of North America, as well as Mexico and the northern countries of South America, the entire coast of Africa, and most of the coasts of Southeast Asia and Japan, as well as Northern Europe and the Mediterranean. So all of these coasts are subject to rising water because of melting of the ice caps. Now, this has been seen relatively dramatically in some places recently. But in our country, if you think about the areas that are at risk of this, much of southern Florida is right at sea level right now. Many of the large buildings in Miami would have to be evacuated, and sometimes rainfall in southern Florida leads to evacuation even now. The more dramatic example, of course, is New Orleans, which has to constantly pump water out of its city in order to stay dry. That city and the cities in southern Florida may very well be uninhabitable in a few years. The drought projection, the other side of this coin. Climate change obviously results in drought. You see the darker areas are most sensitive to drought risk. And once again, Northern Africa, some of the countries in the Middle East, some of the countries in South America, as we all would have predicted. Okay, sorry. Global forest fire increase. Every year we hear California has its massive forest fire problems. This year that's expanded to all of the West Coast. And the global increase in warming of 1.8 degrees centigrade is projected to cause an explosion of forest fires all over the world. And of course, forest fires have many secondary impacts. They impact on soil erosion, they impact on insect spread, they impact on arable land, et cetera. So climate change is, even without any of the things we've talked about so far, the fact that the atmosphere is warming and crops and grasslands are becoming drier is putting us at increased risk for this accelerating process of increased heat leading to increased fires, leading to decreased crop yields, et cetera. Climate change and hurricanes. The average number of Atlantic hurricanes rose from the early part of this, from the mid last century to 2009, a little bit. It's been rising more steadily in more recent years. It's been correlated with the rise in sea temperature and an increase in intensity of these hurricanes has been shown. Now, up until Hurricane Sandy, it was never really felt for sure that a hurricane actually came close to New York. And Sandy was not a hurricane by the time it got here, but it came very close. And whether we called it a hurricane or not, we all remember the tremendous impact of the water surges that came with Sandy. Hospitals were flooded. Bellevue lost all of its power. Patients had to be moved all over the place simply because of flooding, not because of wind, but because of flooding, because of the sea surge brought by that violent hurricane. Violent hurricanes are likely and have been shown to be getting more and more common. So here's a picture of Sandy as it was forming in the Caribbean off Puerto Rico. Air pollution increases in temperature, increased smog, wildfires, pollen production, asthma and allergy attacks, as we talked about. So wildfires, stronger winds from bigger storms. This all sort of merges together into a bigger problem for rapid expansion of forest fires. Some of these fires in California have been traced back to a match that was dropped. Sometimes these were campfires that were left unextinguished. Some of them were started intentionally, but they've become massive fires every single year now. The increased extreme wet weather primes forests during the non-fire season to have more growth that is fuel for fire when it does begin in the drier seasons. So wildfires are projected to increase for the same reasons. Without climate change, they're going up anyway, but with climate change, a dramatic increase. Air pollution. These are the countries of Asia, and you see the countries that have the most air pollution are the ones with the longest bars going out to the right, China and North Korea. Every country in Asia has an increasing problem with air pollution. It's seen particularly in the really populated countries like India and Indonesia. 1.9 million premature deaths in Asia in 2015 were said to have been caused by air pollution. And changes that help reduce climate change would have an immediate effect on air quality and public health. So when we look at strategies to address climate change, we have to look at strategies that reduce air pollution because they can be the most effective global strategies or nationwide strategies. Climate change and food security. In dry areas, changes in temperature affect food security by making increase of evapotranspiration and lower soil moisture levels, so drier soil. Temperature rise will also expand the range of many of the agricultural pests that can survive the winter. And you see these countries that are most at risk are the countries, this is a current map, that have a lot of desert. So all the countries of Northern Africa, Middle East, Southern Russia, Northern China, much of Australia, and our southwest. How do they affect food security? In temperate areas, higher temperatures expected to bring predominant benefits to agriculture. Actually, if everything else was stable, warmer temperatures are generally good for food crops. However, there's going to be an increase in extreme events like heat waves and droughts that counteract that benefit of the higher temperatures. And due to semi-arid and arid pastures, there's going to be a reduced livestock productivity. So we're going to see a stimulus to vegetarian diets, perhaps, a stimulus to out of the field-based meat products. But all this is high-tech stuff right now, and the high-tech is one thing that these countries at highest risk don't really have. So some of the climate change agreements, I mentioned the ones that were already in place in the early 80s. To summarize some of them, you see some of them here. The United Nations has met numerous times on climate change. They, this past year, released a catastrophic report. It was 160 pages long, had many contributors, showing that climate change, in the opinion of these UN scientists, is getting worse and worse. But the more recent climate conferences, first Kyoto, that was 140 different countries around the world. It was the largest international treaty up to that point in response to global warming. Much of the agreements that came out of that were future activities. They weren't present activities. They were not guarantees to lower anything or reduce anything from Kyoto. Next came the Paris Climate Agreement just a few years ago. Same thing again. This was a climate agreement that had more countries participating, 180 some odd countries. President Trump, of course, pulled us out of the Paris Climate Agreement. So it was us, along with, I believe, Somalia, were the only countries that did not agree to this. And the agreement itself, though, was, again, more forward-looking. It was what should be done, what countries could commit to in the future to reduce CO2 release and reduce climate impact of other activities. And of course, this past year, the Glasgow conference, COP26, much of the same. What was different about this one, there were even more demonstrators in both directions outside of the climate conference in Glasgow. And there were many agreements that came out of this. But interestingly, if you read some of the text, there were certainly agreements about what should be done worldwide in increasing, for example, availability of air conditioners. But the availability of air conditioners can be catastrophic for climate change because they release hot air, obviously. And some of the countries that have invested most in air conditioners are getting into deeper and deeper trouble. And India is a good example of that. Some of the elements of COP26, most of which have not been generally agreed to by legislatures all over the world yet, have actually been counteracted already by some of the participants. Indonesia, for example, was really on board for many of the efforts, but by the end, their leadership said, well, this can't really apply to us, though, because we're not ready for any of this. So these conferences serve mostly the purpose of bringing to light some of these issues, but bringing to light is not going to be enough. And many of the participants in COP26 were corporate interests. Some were there for very good reasons, and they have potential corporate solutions, new products, et cetera, new strategies. Some were there to combat efforts at climate change. Global greenhouse gas emissions. You see what the future looks like here. With no action, projection is an increase by 2100 of 8.1 degrees Fahrenheit. That will be completely catastrophic and potentially not even compatible with human life. Current agreed upon things will probably lead to a somewhat lower 2100 temperature, 6.4 degrees Fahrenheit projected. Again, this would be an almost unlivable Earth in many parts of the world. What we're on pathway now to get to is a limit of 2 degrees centigrade or 3.6 degrees Fahrenheit. This has been revised upward a couple of times. It's still the supposed agreement that all countries are aiming toward, but we have to just keep in mind something that's obvious. When you have 193 different countries in the world, talking about risks that are going to play out over nearly a century, you have leadership of those countries that's not going to be around for these changes. Therefore, you have leadership that may not have a personal investment, feel personal risk. In fact, all of us as adults may not be around for much of this catastrophic future that we're facing, but our kids will, our grandchildren will. And we have to remember a graph like this and these projections, because we can't stop just sort of ignoring this as the latest information in the news about climate. This is something we have to figure out what we can do about as a medical profession. And I'll come to that in a minute. So let's talk again about the unique situation of Africa. Again, their vulnerability is the greatest. Their responsibility is the least. The share of population with food insecurity dramatically in favor of Africa. Predicted temperature change, the largest temperature increases than global average are expected to be in sub-Saharan Africa with hotter nights, more frequent heat waves. Southern Africa is going to have a 20% decrease in rainfall, increase in the number of consecutive dry days, an increase in the temperature by 2 degrees centigrade, and that's long before the end of this century. West and Central Africa will be hit only slightly less hard. Food insecurity, already a problem in Africa. The effects of climate change include flooding and drought, as I've mentioned, and serious repercussions on agriculture. Agricultural yields are feared to decrease by those numbers in various parts of Africa. Agricultural yields are already too small, generally, for the global population of Africa. And as we sometimes forget, there are many huge cities and population areas in Africa, and particularly in East Africa, that are often fraught with civil unrest and always fraught with poor access to food, rice, wheat products, et cetera. Livestock and cattle farming will be limited by all of this, and the number of undernourished people in sub-Saharan Africa has already increased by nearly 50% in the last 10 years. There are variable predicted changes by region. I mentioned this before. Higher temperatures could lead to decreased rice production in South Asia. They can also experience a 50% decrease in wheat production because of rising CO2 levels, and warmer temperatures and shorter winters have the potential to decrease food insecurity in Kazakhstan. Now, when we think of these countries in South Asia, former Soviet republics, East Asia, et cetera, we often overlook, when we talk about global strategies, the civil unrest that's often going on in these countries, the political battles that are going on in these countries that stand right in the way of any sort of compromise efforts on climate change amelioration. So what do these changes mean for health? The effects of climate change, as I said, are projected to cause a 250 million increased deaths per year. That's increasing. Malaria, malnutrition, diarrhea, and heat stress. Heat stress is a critical number in this that we don't have a good projection for right now. But heat stress will come in many varieties. If our temperature in New York goes up by 2 degrees centigrade, it will be an incredibly uncomfortable New York. We will be depending on air conditioning for much of the year. And people who can't afford it, people who have to live outdoors, et cetera, will be suffering. And that's New York, what we consider the capital of the world. What's going to happen in the other areas where more extreme heat and less capability to deal with it is going to occur is going to be almost unconscionable. So what are some of the needed next steps? Worldwide reduction in greenhouse gas emissions, of course. Africa is only 2.3% of global emissions. Across Africa, they have to consider agricultural practices, water conservation efforts, coastal zone protection, city infrastructure protection, seawalls, dikes, water wave breakers, improve city food storage, development of early warning systems for floods and droughts. All of this is extremely difficult for impoverished countries. Now let's talk in closing about some other considerations. First of all, COVID-19. COVID-19 obviously has meant an enormous thing to the world. Everywhere in the world has been impacted by this. Only 5% of people in low-income countries are today fully vaccinated against COVID-19. In the United States, because of political concerns and other issues, vaccination rates have stalled in the low 60%. Some countries, particularly countries in Western Europe and Scandinavia, have done a lot better than that. But most countries in the world are sort of stuck in this middle area that is leading to the potential for increasingly bizarre mutations of this virus. What's thought to have been the cause, speculation totally obviously, of Omicron is the prolonged existence of COVID-19 in people who can't eradicate it themselves very easily. So immunocompromised hosts, particularly HIV-infected patients, particularly in Southern Africa, where Omicron was first identified. That's going to continue to be a problem. So Omicron is not, and COVID-19, Omicron will be going away hopefully shortly, but it will be followed by something else. That's some other strains of Omicron, and other COVID strains are already being detected in Europe and in England and now in the United States will follow, because there is this constant potential incubation of new strains of COVID. So what does that mean for climate change? It means an ongoing distraction. This is an immediate issue for healthcare leaders, for political leaders all over the world. And there are many debates about that. Who should handle it? Who should give vaccine to the countries that can't afford to purchase it, et cetera. All of that we're struggling with still, and we will continue to struggle with as the global temperature continues to rise. So let's talk about Venus for a minute. Some of you may have been aware of these observations that have been made about Venus in the last 2 years. It's thought now, based on data from Venus probes and some scientific speculation, that up until 700 million years ago, Venus had a climate a lot like Earth. There was oxygen and nitrogen in the air. There was plenty of water. There were oceans on Venus. There were clouds on Venus. And that was at a time when Venus was considered to be in the habitable zone around the sun, because the sun was smaller at that point and gave out a little less energy. Then about 700,000 years ago, things changed. And since that time, they have changed dramatically. Now Venus's atmosphere is 98% carbon dioxide. So how did that happen? What does that mean? Is that climate change? Is it climate change that was fueled by something else? What happened to Venus is really quite startling. It's a planet that's about the same size as Earth. It has some differences in its rotational features, et cetera, but it's about the same size, and it was in the same temperate zone that we are in now. What happened? Is this the future of climate change on Earth if we don't do something dramatic now? Are we in a better position on Earth because we're smart enough to realize it's happening? Or were potentially, if you believe science fiction, there were people smart enough on Venus to perceive it was happening, and they didn't or couldn't do anything about it. Next, the appearance of phosphine. You may have heard about this one. This was reported in the news just last week. Phosphine is typically associated with life. The appearance of that compound in the Venusian atmosphere was first detected in 2020. So what does that mean? We're detecting something that seems to relate to life in the atmosphere of this poisoned planet. Does it mean that there are organisms that could have developed despite that atmosphere, or are they the remnants of life that existed before Venus got that way? And their only part of Venus in which they can live is in the atmosphere. So let's talk about us. We are trusted and we are looked to. Occasionally we take hits, but many surveys, including recent ones, have indicated that physicians are the most trusted individuals in the United States society. We have to remember that. We have to take responsibility reflecting that. And we have to help to educate about climate change and identify strategies to blunt its impact. Remember, we are sworn to do no harm. But although we are sworn to do no harm, as we all know, doctors have been responsible for catastrophic misadventures in recent history. If you look at the Nuremberg doctors' trial in 1946, the horrendous experiments, so-called experiments, all supervised by physicians, most conducted by physicians, looking at the impact of unanesthetized bone and muscle amputations, introduced infections, low oxygen experiments, freezing all of prisoners. That was all conducted by people in our profession. So we have this wonderful personality, this wonderful reputation, and this wonderful image. But we also have a dark side, and we have to not be on the dark side when it comes to climate change. And being on the dark side may not require us to do anything horrible like I'm listing here, but it may be enough to just be have our heads in the sand about it, because we may have the most well-heard, well-respected voice in society right now to do something about climate change with all of its future implications, and especially with its future implications for our health and for the health of our children and grandchildren. So our responsibilities are to learn and to stay informed, to take action. And you can take action in a lot of ways. You can do this individually. For example, we've done these calculations about appliances that can be unplugged in the house. And interestingly, there was a story in the Times a couple of years ago that if everybody unplugged the appliances in their house that continue to draw current while they're out of the house, and they used the example of VCRs for this, not lamps, they don't continue to draw current, but VCRs do. That if everybody unplugged those things as soon as they left and replugged them in when they got home, maybe the clock would be flickering, but if everybody in our country did that, it would be the equivalent of, I think it was 19 nuclear power plants that would no longer be necessary to provide electricity and for all the issues that nuclear power brings to the climate. We have to be outspoken to our countries, our communities, our colleagues, and our patients. This may not be something that you want to bring up with your patients, or maybe it is. But I've often had patients ask me about this when there's a news story. What do you make of this? What do you think about climate change? It really helps to be informed. We don't have to scare them to death, but it's important that we understand how ominous this future is for us right now, unless we do something about it. So I'm going to stop there, and I show you here a picture. This is the garbage floating in an area in the Pacific Ocean that's about the size of the state of Texas. These are primarily plastic bottles and other plastics that are just floating there as they've been dumped into the environment. There have been efforts to try to contain some of this, to shrink some of these deposits. There are similar deposits in the Atlantic Ocean and in the Indian Ocean, but just getting rid of this stuff is an indication of the amount of work it takes to reduce what we've done with plastics. As we remember, plastic was not very commonly used before the 1940s. Most of us have grown up with plastic bottles, and it seems like a common convenience that we have. But it's how we get rid of them. And climate change has taught us that disposing of things properly can be a strategy that is helpful. Disposing of plastic bottles, and yet recent data suggests that even when they're disposed of in the disposable kind of containers, they don't end up in the right place. As medical professionals, I know all of us have walked out of rooms covered with personal protective equipment, all disposable, sometimes carrying instruments, all disposable, all plastic or all synthetic fiber, all disposed of. How were they disposed of? How did we get rid of them? Back when we had one case of Ebola in New York, it was a patient who was hospitalized at Bellevue. And just to get rid of the clothing and the sheets and everything in that room, because there was a really high focus on how contaminated they had gotten, took many, many trucks to get, he was in the hospital for nearly 3 weeks, many trucks to transport all of that junk to Texas where it was disposed of. We don't have a good way of disposing of things. Our only answer to this is to stop using this kind of plastic. We have efforts in our hospital to reduce the use of plastic straws, but it's still typical to go into Avant Pan, which is our cafeteria, and see plenty of plastic straws, forks, spoons wrapped in plastic, etc. You have to be conscious of this, and you have to remember what you're contributing, if not to your life, to the life of your children, your grandchildren, and their grandchildren. So with that closing, I'll stop and see if there are any questions, and thank you so much for listening to me.
Thank you, Dr. Masci, very much for a very interesting presentation. Joe, we put the any comments in the chat.
Okay.
There is a comment from Dr. Greenberg. As ocean levels rise in the U.S., one of the first areas to disappear is Mar-a-Lago. Unfortunately, NYC will follow not long afterwards. What will happen to the wind machines being built in the ocean for electricity?
Well, the wind machines, it's a good strategy. It doesn't solve everything. And it's a good joke about Mar-a-Lago. But, I think naturally they've become a political football. People don't want wind machines near their coast. They think it somehow impacts property values. Our former president, of course, feels that they make too much noise or something. And that's the kind of ridiculous argument that stands in the way of global or nationally based or even statewide based efforts. I think windmills are a good idea. They're expensive to build. And maybe they will help reduce electricity use and reduce our dependence on carbon fuel. But obviously that will be a long time coming for enough of the world where it will really make a difference in climate change. Climate change, just like COVID, it's not something we can think about just for our community or even our country or our continent. Climate change has to be addressed globally. Otherwise, we're all going to go under together.
Other questions, comments? Joe, I was wondering as we were talking, we don't teach much of this, now some of it's coming into our undergraduate medical education, very little in GME world. I'm just curious your thoughts on that.
Well, look, I think this is something that we need to enlist the medical students, our medical residents, our residents of all specialties, our college students. Interestingly, last week I guess a couple of weeks ago, they put out a call for these summer internships that they offer to first-year students going to second year at Sinai. They get these paid electives. Out of the class, which I think is about 110 or 120 people, 42 selected global health as their area of interest. So there's a real need for this, a real desire to understand it more, and a real interest in it. And many of the people who are coming up behind us have degrees that go far beyond what I ever had in terms of biostatistics, in terms of understanding how you do the calculations to look at impact and to try to design systems that are going to have the greatest impact. So I think it is really our responsibility to bring our students and our trainees more and more into this, because if anybody is going to be living with the immediate impact on their careers and on their lives, it's going to be our trainees. We often in medicine don't think about that very much. We think, well, medicine is going to be getting better, more sophisticated. It's going to be better in the future, more drugs, et cetera, better understanding of diseases. But all of this is going to be getting much, much worse. So understanding the climate impact on health is going to become more critically important for the people we're training.
I agree. Dr. Calder says, Joe, great talk and profound issues. I am very surprised that no one has harnessed the power of the tides to create energy.
Yeah, this is another strategy that's been talked about. The tides come and go no matter what we do. And that's something that has been looked at, but only in a very preliminary way. What can be done about that? And, somehow this has to find its place between seawalls and fans, in the ocean, et cetera, for us to look at seriously. I think the moon pulling on our tides is a tremendous source of energy. And it has to be something that we look at. I don't certainly have the expertise to know how that can actually be translated into usable energy, but I'm sure there are ways to do it. So it's a really important observation. Thank you, Dr. Clay.
There's a comment about solar panels and how they're underutilized, and an example of a friend in Vermont provides all electricity to her home and property and still goes back to the grid. So sort of emphasis on the solar panels.
Yeah, well, look, solar panels are clearly something in the future we're going to be seeing more and more of. I live in a house in the suburbs. We don't have solar panels. Most of the people I know don't have solar panels. So this is going to be a change in perception of why it's important to do these individual things. It's sort of like the electric cars. There's always a debate. Do electric cars actually save energy, or do they just save gasoline? Solar panels clearly are a good thing to have. And that's another individual strategy we can look at that doesn't depend directly, at least, on governmental strategies. We don't have to depend on the national government to purchase solar panels, but they're expensive. They require clear modernization of your house. New houses should be built with solar panels. There's no law requiring that anywhere. It's another area that, it's a good example of something that seems like a great thing to be focused on, but we're not focusing on it.
The next comment actually keeps us at a local level here, where a question, do you know how much medical waste supplies contribute to climate change carbon footprint? And is there any way on the institutional level to try to reduce that?
I don't have a figure to tell you how much it contributes to this. As we all know, if you look at hospitals, which are huge organizations in New York City, nationally, internationally, and also the practice places that are all over the place that use these similar supplies, it's easy to imagine that doing something about disposable medical equipment, having it either disposed of properly or replacing it with undisposable medical equipment, is a strategy that we really have to look at. It has, I guarantee, a very big impact. I just can't give you a percent on it. But right now we're going through the discussion here, I'm sure you've had it at Sinai, what to do with the laryngoscope blades. Should they be the disposable kind, or should they continue to be the undisposable kind? And you can actually make arguments on either side of that. The disposable kind, of course, are plastic. They get disposed of. Are they disposed of properly? The undisposable kind actually have to be sterilized. What's the energy cost of sterilization? I think one thing we're looking at, H&H runs 11 different hospitals, and Kings County Hospital, much to our surprise, has been a model for some of their climate change efforts. They've changed all the lighting in the hospital to be energy conserving lighting, and they've changed some of the disposable equipment strategies. It's really everywhere you look. I think as a profession, we can look at climate change related to medical waste, and we can sit down and try to figure out the direct impact of that and do something about it. Nobody else is going to do anything about that. But everywhere you look, of course, outside the medical environment, we see styrofoam cups. Styrofoam is predicted to last something like 600 years if it gets to the ocean. Styrofoam cups, plastic straws, plastic containers for things, all of that has to be addressed. But one thing, I go through a cycle on this myself. When you say everything has to be addressed, nothing is going to get addressed because it all seems too incomprehensibly difficult for us. But I think we have to, as a medical profession, be the voice for this. We have to point out the things that you're pointing out here, and we have to point them out to a larger audience than ourselves. We have to investigate, do presentations on tide changes, do presentations on what getting rid of medical equipment in a way that is green will mean. Because that we're focused in a way that is unusual in our world. Doctors, to reiterate, are considered the most respectable and the most believable people in our society and in many Western societies. And somehow we have to leverage that and keep focused on this. COVID is going to come and COVID is going to stay and something else is going to follow it. We can't become transfixed away from climate change. There are other things that we're also transfixed away from, like antibiotic resistance, for example. Unfortunately, we have to keep track of all of that. But the one that's going to lead to the biggest catastrophes that make this planet unlivable are all in climate.
There's just a comment here about inhaled anesthetics or massively potent greenhouse gases.
I agree. I've read that too.
Any other comments or questions? If not, I want to thank the Seckler family for supporting us today, and for Joe, for you reminding us about Dr. Seckler. It was great to hear. And congratulations on today's grand round. And it was, as Dr. Cole mentioned, extremely important for us to bring this here, and something that we want to do in the Department of Medicine in grand round. So happy to hear other topics. So with that, Joe, again, thank you, Joe, very much for coming, and congratulations.
Thank you. Thank you, everyone, for listening.